So here's this problem. The twice differentiable functions f and g are defined for all real numbers x. Values of f, f prime, g, and g prime for various values of x are given in the table above. And this is a guide video, so especially at this stage, guys, you really want to attempt as much of this on your own as you can. Okay. Yeah, so when they're telling you that we've got these twice differentiable functions, what they are telling you is that f, f prime, g, and g prime are all smooth and continuous. Okay, that is important in case we need to use a theorem, namely the intermediate value theorem or the mean value theorem. Those are what we usually use for, or always actually that I've seen. Those are the theorems we use for explaining either why a function takes on a certain value, that's the intermediate value theorem, or why a derivative takes on a certain value. Okay. So, yeah, find the x-coordinate of each relative minimum of f on the interval -2 to 3. Justify your answers. All right, guys, so for A, so I want to look, so I'm going to look at f prime to figure this out. All right, and I'm only considering f prime on this interval. I'm going to find where f prime is 0 because those are going to be my critical numbers. So f prime is 0 at -1 and 1. So I'm going to put -1 and 1. Okay. And then I just care about whether f prime is positive or negative on these three intervals. So they're telling you from -2 to -1, f prime is negative. They're telling you on this interval that it is also negative, and then they're telling you on this interval that f prime is positive. So yeah, so find the x-coordinate of each relative minimum. All right, so relative min on f, I guess, or f has relative min at x equals 1 because f prime changes from negative to positive. Okay, so points. You get 1 point for that. All right, and you wouldn't really even have needed to show this here. Just the, that's enough. And then you get 1 point. Okay. Now, for part B. Okay, for part B. Explain why there must be a value c for, c between -1 and 1, such that f double prime of c equals 0. So guys, this is going to be the mean value theorem we're going to have to use for this explanation because we need to, we're proving that the derivative of the derivative essentially is a certain value. So the criteria, the conditions for using the mean value theorem are that the function, in this case f prime, okay, so for mean value theorem, need f prime to be continuous and differentiable. All right, we need continuity on the closed interval, and we need differentiability on the open interval. All right, so I'm going to say it like this. I'm going to say, and if you don't know what the mean value theorem is, guys, look at that thing that I gave you that says where the stuff is and look at it and learn it. All right, so this is what I'm going to say. I'm going to say since f is twice differentiable, f prime is differentiable, which means it is continuous on negative 1 to 1, all right? And I'll say differentiable on negative 1 to 1. These are the criteria for the mean value theorem. You need continuity on the closed interval and then differentiability on the open interval. Okay, now what the mean value theorem says, guys, is that at a certain point within this interval, the derivative is equal to the average rate of change. So I'm going to now state the average rate of change on this interval, the average rate of change of the derivative. So since f prime of 1 minus f prime of negative 1 over 1 minus negative 1, and if you look at the table, it tells you that f prime of 1 and f prime of negative 1 are both 0. 0 minus 0 over 2 equals 0. Okay, so since right here we're showing the average rate of change of the derivative, of the first derivative equals 0. Okay, so since that, by the mean value theorem, there must be a number c, okay, between negative 1 and 1, for which f double prime of c equals 0, all right? And you get 2 points for that. Okay, that's 2 points. All right, that was part B. Now part C. Okay, the function h is defined by h of x equals natural log of f of x. Find h prime of 3. Show the computations that lead to your answer. All right, so this is part C. All right, and we've got that h of x equals natural log of f of x. And I want to find h prime, so I'm going to need chain rule. So the inside is f of x, the outside is natural log. So we've got h prime of x. The derivative of the inside is f prime of x, times the derivative of natural log is 1 over blank, and then what goes back in the blank is what was in there before. All right, so we're going to get that h prime of 3, that's what we're finding, is f prime of 3 over f of 3. I look at the table. F prime of 3 in the table is a half. Yeah, f prime of 3 is a half. And then f of 3 is 7. Okay, so it's 1/2 divided by 7. And you could do 7 over 1. Keep change flip. 1/2 times 1/7 is 1/14. And this is 3 points. Nice. Guys, you could do that. That's a lot of points right there that you can get. Yeah, 1/14. Okay, that was part C. Now we've got to do part D. I think you also can get, this one is a little trickier, but I think you could also get this. All right, evaluate this integral from -2 to 3 of this right here. Okay, so let me write that down. All right, this is part D. And you want to try these yourself, guys. Try them yourself. And if you feel like you can't try them yourself, then do it with me and then come back later and do it again. Okay, give your brain time. Sorry, I'm trying to focus. Yeah, come back later and try it again if you can't do it yourself. Okay, so we're evaluating. All right, so the integral from -2 to 3 f prime of g of x times g prime of x dx. All right, now guys, you're gonna need u substitution. And when you're looking for the u, remember, you're looking for a function that is inside of another function. And g of x is inside of f prime. So just like that. So I'm letting u equal g of x. All right, and when I do that, all right, so right now these are x values. And guys, when you do u substitution on a definite integral has the numbers on the ends of the integral sign. When you do that, u substitution on a definite integral, you should change the endpoints first. Okay, so u is equal to g of x, then instead of, okay, then u is going to be equal to, so u is going to be g of -2, g of 3. All right, so I'm going to have to be doing that there. Okay, now we'll take the derivative. So du equals g prime of x dx. So dx is 1 over g prime of x du. Okay. So now this is f prime of u times g prime of x times 1 over g prime of x du. Right now these are canceling, which is exactly what I want to happen. Okay. And then I look at my table and I want g of -2 and g of 3. So g of -2 is -1 and g of 3 is 1. So this is going to be the integral from -1 to 1 f prime of u du. And I often use parentheses like that. Now we need to do the fundamental theorem of calculus, which tells you to take the antiderivative of this and put it in the brackets, and then you plug that in the endpoints with subtraction between them. What is the antiderivative of f prime of u? It's just f of u. So this is f of 1 minus f of -1. Now I go to the table again. F of 1 is 8. No, f of 1 is 2. F of 1 is 2. F of -1 is 8. So f of 1 is 2 minus f of -1 is 8. So that is -6. Let me make sure I did that before. Yes, that's what I got before. Okay, guys, and then that is another 3 points. That is another 3 points right there.